So for number 9, we're determining whether these statements qualify as definitions. Now remember that for a definition, for something, a statement to qualify a definition, it must be the case that P, if and only if Q, right? And what this means is that P implies Q and Q implies P. So let's check this out and let's see if we can determine whether these are definitions, right? And maybe I'll actually, I'm going to color code these, I think, just so that it's easier for us to see. I'll put P in blue, and then I'll put Q in green. Okay. So let's go ahead and see if this works. Now our P here for number A is f of x is a linear function, right? And our Q, we have our Q when its graph is a straight line. So let's see if this is true. So let's check P, if P then Q. Well, if f of x is a linear function, then certainly its graph must be a straight line, right? So for A, this one over here is true. However, let's look at it the other way around. Let's look at if Q, then P. If the graph is a straight line, then it must be a linear function. And that's not always true, right? Because our graph could look something like this. Even though this is a straight line, it is not a linear function, right? Because it fails the vertical line test. So we can't say that whenever a graph is a straight line, it is always true that f of x is a linear function. So this one is false. Therefore, true and false gives us false. This is not a definition. So this one is not a definition. So let's look at item B. So for item B, our P is f of x is a quadratic function. So I did that in a different color. Should have done that in blue. So our P is f of x is a quadratic function, and our Q is it contains an x squared term. So let's look at if P then Q. So if f of x has a quadratic function, then it contains an x squared term, right? And that one is always true. So we're going to put true because you can't have a quadratic function if it doesn't have an x squared. Now let's look at if Q then P. If it contains an x squared term, then it is definitely a quadratic function. Is that true? Well, not really, right? Because if you look at the function x cubed plus x squared, it does contain an x squared term. However, it's not a quadratic. So it's not always the case that if you have an x squared term, you have a quadratic, and therefore this is false. So since you don't have a bilateral relationship between P and Q, this one is not a definition. All right, so let's look at item C. So for C, our P is, M is a perfect square, right? So our P, let me highlight that. And our Q is, M is equal to n squared for some integer n. So is this true or not, right? Let's think about it. If P then Q, if M is a perfect square, then M is equal to n squared for some integer n, right? That's the definition. So 9 is a perfect square because 9 is equal to 3 squared, right? So this is a true for if P implies Q, and let's look at if Q implies P, right? So if I have that 9 is equal to 3 squared for some integer n, then M is a perfect square, right? There's no, would not be able to find M is equal to n squared for some integer n if it were not a perfect square. So this works both ways, and therefore it is a, yes, it is a definition, because if P then Q, and if Q then P. So let's do D. A triangle is a right triangle, so that is our P. Triangle is a right triangle, and our Q is the sum of its two interior angles is 90 degrees, right? So let's see. If P, then Q. If a triangle is a right triangle, then the sum of its interior angles is 90, right? And this is true. So whenever I have P where it is a right triangle, it must be the case that, we'll call this alpha and beta. It must be the case that these two add up to 90, right? So I'm going to have these two add up to 90 plus 90, that's 180. So if P then Q is definitely true, how about if Q then P? So when the sum of its two interior triangles are 90, so when we'll call it A and B. When A and B is equal to 90, this must mean that this other angle C, right? C is equal to 90, because that's the only way that we would get 180. So it definitely means that if the two interior angles sum up to 90, then the third angle is 90, and that means that it is a triangle. So if P, then Q, and if Q, then P. So yes, this is a definition. I'm just gonna, I'll just put it in terms of knowing yes. Okay, now let's look at E. So two lines are parallel. This is our P. Lines are parallel, and our Q is their slopes are the same number, right? Now for this one, we have if P, then Q, and if Q, then P. So let's see, if lines are parallel, then their slopes have the same number, right? That is true, because the only way for two lines to be parallel is if they have the same slope, right? You can't have two lines that are parallel with different slopes, because then they would intersect at some point. So if P, then Q is definitely true. Now let's look at if Q, then P. So if the slopes are the same number, then two lines are parallel. Well, that is not true, because I could have collinear lines, right? This could be my one line, and then on top of it, I'll put this line over here, this pink line, and these two have the same, they have the same slope, but they are not parallel, because parallel lines, they never intersect. And here in collinear, they intersect at all points, right? So it's not the case that when you have parallel, when the slopes are the same number, it is parallel. So you can't say that if Q, then P. So because it is not bilateral, this is not a definition. And lastly, we're going to have, oops, I shouldn't have done that. Yeah, so no. And lastly, we have P, a sundial. If it is a sundial, right, then it is an instrument for measuring time. So P, it is a sundial, and Q, it is an instrument for measuring time. So a sundial definitely is an instrument for measuring time, right? So P, then Q is true. If it is a sundial, then it is an instrument for measuring time. So P implies Q is true. However, let's look at Q. If Q, then P. So if we say that if it is an instrument for measuring time, then it is a sundial. And that's not true, because we do have other instruments of measuring time, right? Like a digital clock. So it's not the case that if it is definitely an instrument for measuring time, then it is a sundial. So this is false, and therefore we do not have a bilateral relationship, and therefore this is, it is not a definition. So really, the only definitions that we have are C and D, because they're the only ones where we have a bilateral relationship, that if P implies Q and if Q implies P.